today then. Okay, so the topic that we are looking at today is going to be our reading and drawing data topic. So the subtopics that we've got here, we're going to look at probably the most important part of today really is two-way tables. Very common for level 1 and level 2 learners. It's also really commonly linked in with our probability questions for level 2 learners. And this will be in our next topic following this one. So we're going to look at two-way tables, how to read them first of all, and what they are. And we're going to have a little bit of a look at frequency and tally charts. It tends to be more common for level 1 learners, this topic, but I want to make sure that everyone's very happy with how to read these types of tables and charts. What we then need to do is have a look at bar charts, and this is the most common for level 1 learners. It's not strictly for level 1 learners, it can be on level 2, but it's more commonly placed there. And we're going to have a very quick look at conversion graphs as well. So these are something that they've popped up once or twice. There's not really an ideal place to fit them in. It's just really, so long as you can read a graph, it's X and Y axis, you'll be okay with these. But they have popped up a few times, so it's definitely worth paying a bit of attention to them. Again, more of a level 2 topic. We're then going to look at our overall most common topic for level 2. So I should have added this to the PowerPoint, but scatter graphs in themselves, correlations, lines of best fit, these are only for level 2 learners. These will not be for level 1 learners, so please bear that in mind. We're then going to have a little bit of a look at pie charts at the end. Again, they can appear on either, but they are more common on level 1 papers. By me saying that, I've never seen one on a level 2 paper. I have on a level 1, but I've only seen maybe 2 or 3 of them. They're not overly that common. Okay, so two-way tables then. These are ways that allow us to display frequencies, obviously frequency meaning the amount of things in different categories. We see them very commonly on like bus stops and train stations. They're quite common. And we read them by selecting one category and then moving along horizontally or vertically to the second category that we want. So if I'm getting the train from Brighton to Southampton, I can look down and it will tell me maybe the time at which that train is going to arrive or how long that journey will take, or something to that effect. Essentially what you end up with is something that looks like this. You tend to have these overall total columns as well, and it's just important to kind of be able to read this information and know exactly what we're reading. So it's the idea of kind of measuring across and up or down and across. If I wanted to know, for instance, how many female dogs were there, well, I can look here. I've got females here and dogs here. So it's going to be this box here. There are 9 female dogs. Okay, fantastic. If I wanted to know, well, how many male animals were there in total? Well, I've got 42 male dogs, 10 male cats, and then I've got my overall total of males here, 52. If I wanted to know just how many dogs were there, okay, dog here, male, female, and total, 51. So you can see you can read a lot of information very easily from this, and you can kind of look at a lot of statistics and probabilities from this as well. This is a very useful one because it's the overall total, as you can see down here in the bottom right, is out of 100. So you can see how this could be linked with percent. I could easily say, what is the percentage of male dogs? If you look at male and dog, there's 42 of them. So therefore, it's 42 out of 100. Quick conversion, it's 42%. We're not going to look too much at that idea or that concept of probability. That's for our next session. But just so you're aware, that is where it tends to link. We tend to get a question about a table like this. And then when we move on, it then tends to have an extra kind of tag on probability question after, but we'll see that next time. Okay, so essentially, we may be asked to either read data from a two-way table, and if you ever get given a table and you're asked to read information from it, that's going to guarantee you 1 mark just for reading something. Even if it looks very straightforward, you're still doing a mathematical skill. You're still showing that you know how tables work, so you get the mark. Or you might have to complete a two-way table. When you're completing a two-way table, if anyone does Sudoku or anything like that for fun, then you're going to be even better at these. But they are very very straightforward. It's just a case of finding information. There'll be one piece of information missing, and you'll have two pieces of information, so you can then find out, or three pieces of information. You essentially fill in the blanks, and then once you've got those blanks filled in, you can actually double check in every single way. So it's very difficult to get these questions wrong. So if you can, use a calculator, have a look and see if you can fill in these 4 missing categories. If you want to obviously send your answers over and let me know what category you're talking about. So the amount of football games that were lost, how many do you think it is, etc. And then we can review this in just a second. Okay, quite a lot of answers flying in already. That's always good. Okay, so number of football games lost. Yeah, so Alicia, Emma, absolutely spot on. What you'll notice is people always start from different places on here as well. Caroline, yeah, the total 1 there. That's brilliant. Overall total, yeah, absolutely fantastic, guys. So, okay, no one seems to have an issue with this, which is absolutely brilliant. So, what I'm going to do very quickly is just start going through this because I can see that everyone's had a little bit of a go. And again, there are with this one in particular, you could start from any of these. Sometimes it might be that there's only maybe 2 places or 3 places you can start from. It's always dependent, but it's also preference as well. For me, I'm going to start from the left. So I want to know, well, what was the total amount of games that were won? Well, I know that 8 games were won in football, 4 games were won in Alicia. Yeah, no problem there. So 8 games were won in football, 4 were won in rugby. So in total, there was 12 games that were won in total there. Okay, so what about the amount of games that were lost in football? Well, to work that out, I know in total there were 20 games played. 8 of them were won, 5 of them were drawn, so therefore the rest have to be lost. And you can work out in either way. You could do 20, take away 8, take away 5, or you could do 8 plus 5 and then take that away, or 8 plus 5 and add up the difference, whatever you need to do. You should get the answer 7 there for that one as well. Mary, yeah, brilliant. So I did move on quite quickly there, but I could see that people were obviously, it's more just typing this out, which takes a little bit more time. Okay, so the amount of games of rugby that were drawn then is going to be 3. And the nice thing is with this one, as a prime example, I can work it out in 2 different ways. I can look at the games of rugby that have been played and say, well, in total, there were 16 games. 4 of them were won, 9 of them were lost. So that takes me to 13 in total. So there can only be 3 games that were drawn, which we would put in there. At the same time, I could look at it from the top and I could go, well, in regards to games drawn, there was 8 drawn in total, 5 are from football, the rest must be from rugby. So again, the answer has to make sense both ways. So that's why this type of question is so good, because it's always going to allow you to double check your answers. It's almost impossible to get wrong. If I look here at the overall total as well, I can work out from the total of all the games won, lost and drawn, so 12, add 16, add 8. Or I can look at this and say the total number of football games, the total number of rugby games, 20 and 16. Overall, I've got 36 there. Again, you can double check all of these. Now, the great thing about this really is how many marks it's worth. This question on its own, this is an exact idea and replica of it, you would get 3 marks for this. So if we put that into kind of consideration and we think about it, that's the same as you'd get for a compound interest question, 3 marks. You will get 1 mark for putting a piece of correct information on there, 2 marks for putting the majority of the pieces on there, 3 marks for all of them. it's a very nice, easy 3 marks to get. So we are very happy with this question. Really keen, hopefully it pops up. We will come back to this. We're going to look at it more in our next session because we're going to continue to build on it in regards to how this links in with probability as well. If you are working through, or if you wanted to at any point, you can obviously have a look on the actual PowerPoint. There are some extra practice questions here. So if you're watching the recording, you can just pause now quickly. And obviously all of the answers are there for you being revealed. But I think us as a group at this point, I don't think we need to spend any more time on this. Okay, so a little bit on frequency and tally charts then. So just so everyone is quite happy with this, we did see these in our last session when we talked about averages and statistics, but just to clarify what they are, more of a common thing for level 1 learners to be asked, and it might just be that you're asked to complete a frequency or tally chart. For level 2 learners, we need to know what they are as well. Oh, okay, Nisha. Yeah, I see now. Is it okay now then? Are you quite happy with the?
Yeah, I had just read the because I'd done it earlier on. I had accidentally read the wrong table when I was putting my answer in, so I didn't get confused. I just literally just put the wrong answer over by mistake.
Right. Okay, got you. Well,
but no, I got them all right.
Oh, okay. Well, that's an absolute win. There's your 3 marks. I can't actually
Thank
award
you.
them to you, but you would have got them. So.
No, thank you.
Okay, so frequency and tally charts. We've seen them in our previous session. The idea with this is basically it's how you would collect raw data. If you were in a position where you needed to find something out and you were doing some research, first of all, you would collect a tally. You know, it'd probably be more of a tally on an electronic device now as opposed to just a bit of paper, but whatever it might be. But you would collect the tally, and the tally itself, as we can see on the right there, it's just 4 vertical lines, and we put a line through it for the 5th. The reason being is that people find it incredibly easy to count in 5s. It's kind of just something that's embedded into all of us. So it makes it very easy to total all of these up. So we put our 4 lines down, our 5th line across, that's our tally. So if it was 23, we'd have 4 blocks of these 5 and then 3 remaining at the end. What we then do is once we've collected this, we then have the frequency, and all the frequency is the numerical value of the tally. So if there was 17 kind of lines, so 15 of them in obviously groups and the 2 remaining, then you just write 17. That's all the frequencies. It's just saying how many are there. This is just a rough way of doing it. So an idea of a question. So this has popped up for level 1 learners before. We're not actually going to kind of go through this, but I just wanted to show you it. But this is an exact question from a past paper. So this is Daniel, or Danielle, I think it is even, collects data about the ages of people who attended her fitness class. Complete the frequency columns for Danielle. All it's asking you to do is literally read them. Okay, well, I've got 4 here, 5, 10, 11, 12, 5, 10, 15, 16, and 5, 6, 7, and 8. Really, really nice 1 mark question there. Sometimes they do ask you to, it might give you some information as well. So it might give you this information here and then say an extra 5 people attended this week and they were all under 18. Add this to the diagram. So then you might have to add the tally on and then the frequency or something similar. You can see how it can kind of vary with this type of question. I have seen it once or twice where they've just asked you to draw this essentially from scratch. And again, it's just right, you know, okay, well, we've got the age, the tally, the frequency. That's what we're thinking about as a level 1 learner. So moving on then, we then go to our bar graphs. So we've got our, what we would do initially is we collect the data as a tally, then we put it as a frequency. Frequency is great, and we can look at it and we can obviously work out what number is bigger, what number is smaller. But if there's a lot of data, it gets quite hard to kind of see the difference between them. That's where we'd use a visual representation, such as a bar graph, a scatter graph, or a pie chart. They all have kind of different advantages and disadvantages. There are some extra resources on this on the Classroom if you want to read up more. The main thing for us with our course is that we know how to construct these and we know what they look like. So bar graphs are most common for level 1 learners. and they are best for comparing what is called kind of discrete data. It's more how many of this are there. It's just looking at frequencies, very good for spotting a mode if you were kind of looking into it that way. So in functional skills, we may be asked to construct a bar graph from nothing. And again, this could be for level 1 or level 2. You might be asked to construct a bar graph. With that being said, it could also be a line graph. But again, the difference between if you were to construct either, you'd get the marks. That's why I only really highlight bar graphs, because bar graphs and line graphs are really the exact same. It's just some people prefer to draw a line connecting all of the pieces together if there's something in common. Maybe if along the bottom it was, you know, Monday, Tuesday, Wednesday, Thursday, Friday, so it shows a bit of a time correlation there. So if we are asked to draw one of these from scratch, we can actually get the majority of the marks just from planning. Really, we don't actually have to put all the correct data in there to get the right answer, to get all of the marks. And this is a bit plotting this from scratch as well. It's not the only type of question that we get. Sometimes we get asked to read information or add information to a graph as well. So if we look at what these bar or line graphs need, then here's an example of one. And this is, again, all of the examples I'm going to show you are just kind of loose examples. In the actual exam, we will look at an example of an actual exam question as well. These are going to be a lot more specific. Here, I couldn't exactly tell you what this value is. I know it's between 25 and 30. Nearer to the lower end, I'd probably say that would be 26. This one I'd probably say was 27. But it's not exact, whereas ours will have more kind of squares on there, more of an ability for us to read into it further. So this is what a bar graph looks like. The great thing is, for us, actually labeling the axes and the bars is going to get us 1 mark there. So with level 1, I've seen this before where they've drawn the up line for you, the across line, and they've actually given you the first starting measurement. So maybe you're counting up in thousands of pounds, and you know how much was raised for a charity, and you want to apply it on a graph. And it might have the first step there of £10,000. That's fantastic, because then you know the next step's going to be 20, 30, 40, and so on. But simply for writing the names of what you have and the bar's own labels, you're going to get 1 mark there. So in this case, just for saying what gadgets there are, the number of them up the side, and then listing what the gadgets are, that's going to get you a mark on its own. The next thing we need to do for our second mark is make sure that we use an appropriate scale. So by an appropriate scale, it needs to be consistent and it needs to be linear. So it can't just be, you know, if I was reading this data here, it can't just be, okay, the first one is going to be 27, then 31, then 45, and then 106. All that, it would tell me which one has more, it would tell me how much it has as well, but the actual link between the graph is then lost. I can't see visually how much more something is or how much less. I can't compare them very quickly and easily. So it's got to be a linear scale. In this case here, you can see it's gone up in 5s. That's absolutely fine. Sometimes it will go up in 10s, 100s, 1000s. It tends to be increasing in units of kind of 5 or 10 seems to be the best way forward, be it 50s or 100s, 1000s, whatever it might be. The thing to bear in mind is that you don't need to start from 0 either. With some things, again, if you were talking about the amount of sales that a company made, it might be that all of the sales were, I don't know, around 20,000. So we're not going to start at 0. And then let's say when we looked at our scale, we're like, okay, well, they range between 20 and 30,000. So we're going to have 20,000, 30,000, 40,000, oh, sorry, 20,000, 21, 22, 23, 24, 25, etc. You don't have to start all the way down at 0 and have 1, 2, 3, 4, 5, 6, because all that's going to be is your graph's going to be huge, and it's only going to be the very top part that we're going to be looking at. So you can actually just have it starting at 20,000, 30,000, whatever it is that you need there. We'll look at another example of this a little bit later. So that's your second mark. The third mark is just simply for adding the actual bars on there. one thing that I'd recommend, if you're drawing it from scratch, it's very easy to obviously spot and know your own scale because you've made it yourself. Sometimes if they do give you a scale, or if we're trying to just read the data off of a graph, it can be a little bit confusing. So just make sure that we're aware of, okay, well, one big square is worth, let's say, 10. So that means each smaller square in there is going to be worth 2, or whatever it might be. Just so people are aware as well, I mean, this is how we tend to see graphs. It could be that, you know, if you're worried at all, like, oh, how do I know which way round it goes? Obviously, if I put the numbers going up here, I know that my graph or my bars are going to extend upwards. I tend to have more space up the page than I do across the page. With that being said, if you were to plot this the other way round and you had the gadgets on the left and the numbers on the bottom going across, you'd still get all the marks. It's just your lines are going to, or your graph is going to go this way, or like horizontally instead of vertically. So just as another example here of kind of like what this looks like, and again, it's not the overall best example in regards to what we're going to see, but just as a kind of visual idea, if we were given this kind of data and asked to construct a graph, then what we'd be looking at first of all is, okay, well, first of all, what guide pack is it? And then second of all, well, what is the number of guides that we have? By then putting this, like labeling what kind of totals or columns we're going to have, that's going to get us our total first mark there. Okay, well, what scale am I going to use here? Because it doesn't really start from 0. What you can do here, and what's really, really useful, is just have a look and just think, okay, what is the range? At a glance, I can see, I think the lowest value is 21, the highest is 28. So the majority of my information here is going to fall between 21 and 30. It's always worth, you can go a little bit higher if you need to. You don't have to go too much higher though, because if you did get a random extra bit of data that's way too high, then you redraw your graph to consider that, but we're not ever going to be asked to do that. It's testing that we can draw and work with data, not that we can actually do it in real life, essentially. So with this one, actually the scale itself, it's only going up to 30, so it's not really too kind of far off. We could probably start at 0 with this one as well. You know, 5, 10, 15, 20, 25, 30. You wouldn't have to. I mean, if you'd rather, knowing that it starts at 20, you could very easily maybe put 20 as your first point here. To have 20, 25, 30, 35, 40, and so on. It's just going to kind of switch the bars down a little bit, but it does still show you the differences between them and the correlation and links between them as well. Oh, really good question, actually. Yeah, so in the exam, and this is where it differs a little bit, obviously, if you're doing the exam on a computer, you're not going to be, well, you physically can't hand draw anything. If you're doing the exam on paper, then yes, definitely use a ruler. Make sure it's nice and neat. The main thing with the ruler is making sure that it's measured off at the correct kind of line, really. Draw it all in pencil. When you're very happy with it, then go back and go over it in pen. You do want it finalized in pen as well, for the examiners to obviously mark it fully. So I know it's that idea. It's always drawing in pencil, you know, writing in pen, but we want to make sure all of our drawings as well, we have put them in pen to make sure that they are permanently there and they can't be altered at all. Okay, so another type of question that you might get in regards to bar graphs is reading and, or just kind of like reading data from them, essentially. So what we've got here is a bar chart that shows the number of miles that Paula and Rose have run from Monday to Friday in a week. Okay, so we've got our key there, so that tells us who's who. So the horizontal lines represent Paula and the diagonal lines there represent Rose. Okay, fantastic. So one question might be asked is something like this. It could just say, Rose runs further than Paula on Monday. How much further? So I'll give you a minute, actually, in all fairness. So this would be, obviously it would be a 1-mark question, but I'm pretty certain, definitely for level 1 learners, this would be a 2-mark question. Because although the sum is very nice and straightforward, you are also reading data. So you have to read data and then complete a sum. So it's at least 2 marks, really. I wouldn't be surprised if that did appear on a level 2 paper, that it'd be the same, but obviously with level 2, they tend to make things a little bit more difficult and put a little bit kind of extra, it'll be slightly different numbers, if anything. Okay, so if we have a look at this end, so Rose runs further than Paula on Monday. How much further? So yeah, everyone that's popped your answer in, absolutely fantastic. Well, first of all, we need to read the information off the graph. Well, on Monday, there it is. Paula, that's the diagonal line, runs 6 miles, as we can see here. And Rose runs... Oh, sorry, no, I read it the wrong way around. My bad. So Rose runs 6 miles, Paula runs 3. So how much further has she run? Well, what's the difference between 6 and 3? We're looking for the range again. 6 minus 3, or go from 3 and count up. You should find that it is a 3-mile difference, and that's going to be probably 2 marks for you. The next type of question that you might be asked is something like this, perhaps, where you are asked to add some data to a table. So in this case here, it's saying here, and you wouldn't see all of these in one go, but just to give you a bit of an idea for level 1 learners. So Rose ran 6 miles on Thursday. Use this information to complete the bar chart. Just draw it on there, and thank you very much. I'll have that extra little mark there. For level 2 learners, as we'll see moving on, when we look at our scatter graphs, it is common for you guys to get kind of like a 3-point question, where it is similar to this, maybe reading some information, drawing a little bit on, and then working something else out. But for level 1 learners, it's not very common, especially with bar graphs. Okay, so the final type of question you might get is just a bit of a bigger, bit of a longer question. For level 2 learners, it could be something similar like this, where you have to work out maybe an overall total, or it might even be giving you some ideas about kind of the comparisons used as well. So it might be, you know, what percentage did Paula run further than Rose on Tuesday, or something like this. So they can ask you a little bit more information in there, so do just be aware of that. So for this question, it is worded a bit strange, but they can do it. So let's have a bit of a look. So we've got Rose is not going to run on Saturday. So our graph there goes from Monday to Friday. So on Saturday, Rose is not going to run. How many miles would Paula have to run on Saturday so that the number of miles that she runs from Monday to Saturday is the same number of miles that Rose runs from Monday to Saturday? Quite a long kind of worded problem there. Essentially, it's just saying how much further has Paula, or how much further has Rose run, really. But they've, again, worded it in a bit of a different context. So have a little bit of a go, have a little bit of a think, and then pop me over some answers when you think you've got them.
Tom, the chart only goes up to Friday.
Yeah, it's why
Oh.
that's why it's such a weirdly worded question. They could have just said, you know, how much further has Paula run? But yeah, so it's basically saying that on the Saturday, so after this, Rose is not going to run, but Paula will, and she wants to make up the difference. So it's just asking you to work out the difference and then state it there. But yeah, it's quite strange, though, isn't it? It's just a bit very longly worded.
Okay, thanks.
No worries. Tracy, yeah, all good there. Again, I think even if you did say that they were running that many miles, I think you'd be absolutely fine. I don't think they'd dock you a mark there. They know what you're talking about. So, okay, Mary, yeah, I'm liking that. So starting to work this one out. So again, with this one, it probably would be, I mean, for level 1 learners, you're looking at a 3-mark question here, really. You know, you've got to work out one total, another total, and a difference. Could potentially be 4 because you're reading it from data as well. So It could be either way there. Okay, so getting a couple of different answers in then. So it tends to be a few people have said 5, a few people have said 3. That seems to be the kind of like the vote there. I think the majority is going with 5, I think. Oh no, someone's changing their mind. Oh, it's getting tense now. I'm liking it. And then Caroline joins in with 5 as well. So 5's looking like it could be the winner. Let's have a bit of a look then, and we will go from there before I turn into like someone talking like there are horses racing or something. So, okay. So we have, first of all, how much has Rose run? How many miles has Rose run? Yeah, we're going to go through there. We're going to add up all of hers. So she's the diagonal line. So we've got 6 and 4 and 6 and 6 and 8. So we're going to add all of them together and we've got 30. How much has Paula run? Paula in total has run 25 there. So the difference between them is going to be 5 miles. So if you said 5, absolutely amazing. If you didn't and you said 3, then don't worry, it's not the end of the world. Again, little errors, little miscalculations, it will happen. You know, we are not like designed, we're not kind of completely set in these kind of mathematical ways. It's not actually the most natural thing in the world to us. So if you have said 3, it might just be a slight miscalculation, but you're still probably going to get 1 or 2 of the marks there. Okay, so what we're going to move on to now, we're going to have a quick look and a quick talk about conversion graphs. And then we will kind of put a bit of a pin in it there. We'll take a quick break. And then we'll come back and we'll look at our following topics after. So we'll look at our scatter graphs and our pie charts. Okay, a conversion graph then. So conversion graphs are sometimes in functional skills, we might be expected to perform a conversion between units by reading the information from a graph. So we've done this before, and we've seen questions like this where they do this with ratio. So it will, give you a question and it will say, 1 foot is, I don't know, 12 inches or whatever, or 3 feet equals 1 yard. It will give you a ratio and it will expect you to use it. Sometimes they give you a visual kind of graph to get this data from as well. So instead of having to actually go, okay, well, what's 1? And then use that 1 part to find the value, we don't actually have to do any maths, we just read it from a table. So they're actually quite nice. It's essentially just a visual way of dealing with 2 things that have direct proportion. So it's all to do with ratio. It's exactly the same kind of idea. So to solve these, we simply just read a value on one axis and measure it across to our conversion line. So there will be a line there. It tends to just be a straight diagonal line like this. It doesn't have to go through 0. It doesn't have to start anywhere, but it'll just be a straight line. And you essentially just measure across and then measure down to get to your answer. So it's just a lot nicer, quicker, and easier way of doing ratio-based maths. You don't have to do any maths. You just look and draw across to a line and then draw down. You just have to have a ruler. That's it. So as an example, it might be something like this. So this is a graph that explains how we would convert from gallons to litres or from litres to gallons. It will work either way. So with this one in particular, again, if we had the actual measurement, I don't know what it is off the top of my head, in all fairness. I think there's about 3 point something litres in a gallon. I'm not entirely sure. I've not really ever learned about gallons, really. But there would be a number for it. So you could always kind of use the mathematical way. You could get a more specific answer that way, I guess, if you were to work out, okay, well, I want to know exactly if I've got, in this case, 60 litres, and I know that 1 litre is 0.0132 gallons, then obviously I can work out exactly the amount, but I can do it a lot faster on here. So to convert from 60 litres to gallons, all I'm going to do, first of all, I'm going to find where is 60 litres. Right, there it is on my x-axis. And then all I'm going to do is measure my line up. So I'm going to get my ruler, I'm going to draw my line straight up until it bumps into the conversion line. Then all I'm going to do is measure it off, and this will tell me exactly what the amount is in gallons. Now, it's never going to be an exact amount. Not like, you know, when we solve this mathematically, we are working out the exact amount, and we could increase the number of decimal places if we want to make sure that, you know, we know this as clearly as possible. That's not going to be the case here. So by measuring this off, they will accept the range of answers. And this is what I meant in regards to the graphs. This is what they look like. So you can see here, okay, well, you've got 0 there and then 5. In between them, there are 5 lines, which means that each line equals 1. The gap in between would be a half, and they would expect you to be able to measure to a half amount of distance. That's the degree of accuracy that they'd be going for here. So for this one here, if I measured that off, I mean, there we can kind of say it looks more like 13 exactly, but anywhere between that range of 13 and 14, and they're going to give you the mark there. So that is how this a conversion graph works. You could do this the other way. It could say convert. I mean, if anyone, it might be a bit small on your screen potentially, but would anyone be able to give me an estimate for the conversion? Can anyone convert 20 gallons into litres? It's quite a nice one on there I've just spotted. So any ideas? 20 gallons up here. How many litres do we think that would be as an estimate? You know, I know it's, yeah, absolutely brilliant. So Emma, yeah, Tracy's spot on. Okay, yeah. Right, so just to explain that one then, because there was one or two answers there which were a little bit off. But again, that could just more than likely be to people looking at this on a phone. So my gallons is here, 20 gallons. I'm measuring from gallons all the way across until I hit my conversion line. Then what I'm going to do is measure downwards. So my conversion line there, okay, fantastic. So it's going to be about 90. So that's the way that we're going to kind of measure this one up. Oh, okay, that's spot on. So someone's just kind of said that, oh, I kind of measure it the other way. I went from litres and kind of measure it the other way. It can happen. It's you know, it's an easy kind of error that can occur. It can happen to anyone. Just remember, it's a 1 mark question. You know, I mean, it's actually probably one of the nicer things about the larger sized questions is that, well, actually, there's a lot of steps in there, so it's very difficult to not score anything. With these ones, you know, if you make that little error, then you might just miss the mark. But hopefully now that is cleared up, it's a nice visual way of kind of solving a ratio-based problem in regards to direct proportion. Okay, so we've got scatter graphs and pie charts to look at now. But I think we will take a quick break there, and then we'll carry on. But again, it should be a bit of a nicer session today. So can I ask everyone to be back for 6 o'clock, if that's okay? So just a quick 10 minutes, grab a cup of tea, whatever you need, and then we can go on from there, okay? Okay, so the next couple of topics we're going to look at then, so scatter graphs in itself is the main question that pops up for level 2 learners. So in regards to what these are, scatter graphs essentially just show us correlation. So correlation is just a fancy word for how closely things are related, or how, if there are any links between 2 different types of information. They're best for showing changes in data over time with continuous data. So when we use a bar graph, it tends to be what we call discrete data. Again, you don't need to know the terminologies, but discrete data is very much, it's either in this box, or it's in this box, or it's in this box. You know, the make of car, for instance, it's either a Ford, or it's a Mercedes, or it's a BMW, whatever it might be. With scatter graphs, it tends to be more of looking at changes over time. So, you know, maybe something over an amount of time, maybe people running in a race, you know, the amount of time to complete it and how long they've run for, or something to this effect. So in functional skills, we may be asked to read data from a line or scatter graph, to create a line or scatter graph. So where it says line graph there, that is the exact same as scatter graph. Sorry, I need to change that. But to create a scatter graph or plot data on one that already exists, it might just be add this information to the graph. To state if there's a trend or a correlation or a link between the data, and to potentially draw what is called a line of best fit. Like I was saying, it tends to be with level 2 questions that it will be maybe 3 of these. So it will be one graph and it will just ask you 1 mark for each thing. How long did this person take? Someone else has completed the race in this amount of time. Add the data to the table. What is the trend of the data? Something like that. And again, we've got some actual exam examples of this as well. Oh, sorry, you could also be asked to use a line of best fit to make an estimate as well. So when we're talking about correlation then, and the description of correlation, we need to know what is this fancy word all about. So we might see graphs that look like this. Obviously, these don't have any context. This is just y against x. So if I give it a little bit of context, it makes it a little bit easier. So what we'll have here is IS, that stands for ice cream sales, obviously, and then this can be temperature, why not? So in regards to these, the word weak and the word strong, you do not need to know. They're just to give you a little bit further information there. So this is a weak correlation or a weak positive correlation. This is a strong positive correlation, but you don't need to state if it's weak or strong. You just simply need to say if it's positive or the opposite, which will be negative. A positive correlation, it is a link between the two kind of outcomes here. They're in proportion, but they're not in direct proportion. So it's not for every increase in temperature, there are more ice cream, there are 10 more sales of ice cream. It's never going to be exactly that, but there is a rough link between them. What it will be is that as X increases, so does Y. So as you can see here, as the temperature gets higher, so does the amount of ice cream sold. So if I were to read off this data, so let's say I read at this temperature here. Okay, so that's more sales sold than, say, a point here. For this in particular, the best way, it might be that you're given this graph, let's say it is ice cream sales against temperature, and it might just say, state the correlation. So it could say, what is the correlation? What is, or state the trend? What is the link? Talk about the pattern or describe what's happening. It all means the same idea here. It's just saying, what's the link between them? If you forget the fancy word correlation, just writing positive, it might get you the mark, but you really do want to say a positive correlation, meaning there's a positive link. However, if you said positive link or positive kind of link between them, then that will get you the mark. But you can also just describe what's happening. As ice cream sales increase as the temperature increases. At lower temperatures, less ice creams are sold. Any of them are going to get you the mark there. In regards to the strong and weak kind of aspects, what you can see here is this would be a strong correlation just because, as you can see there, the points are a bit closer. If you imagine there's like a middle line through there, they're all a bit closer. If there was just one straight line, they'd be in direct proportion. It means that they're close, more closely linked than obviously here where they are still linked, but there's a bit more space between the points. So this would be a positive correlation. The opposite of this then is going to be a negative correlation. And you can see here the strength of the correlation is a little bit stronger. So here, this is quite a strong correlation. It's very close to really being a straight line. I can almost draw a straight line through that. Whereas here, it's a bit more variable. The stronger the correlation, the more reliable our estimate is. And we'll look at this when we draw our line of best fit. To give this some context, let's say this is going to be the amount of money in pounds and this will be HT, which stands for holiday time. So again, it's all about just describing what's happening. If you saw this graph, you could just say there is a negative correlation and you will get the mark. You could say there's a negative link between these aspects. That would also get you the mark. Or you can describe what's happening. You have more money at the beginning of the holiday than you do at the end. They are in inverse proportion. As one is higher, the other is lower. As one increases, the other decreases. Which makes sense in that context. You know, when you first get on holiday, you've got all the money in the world, you've just got there, like, yes, you find that cocktail bar and things start to go downhill. By the time you've been on holiday for 2 weeks, you're not after the cocktail bar anymore, you're just kind of at the, the all-inclusive bar, dreaming of cocktails, essentially. So again, this is an idea of a negative correlation. Obviously, there can be no correlation as well, but they will never ask you about this. So it's very similar to, if you remember when I said about the mode, if they say, what is the mode? There will always be a mode. I've never seen them ask for more than one mode, but there will always be a mode. There'll be something that is more common. The reason being, if they said, what's the mode? And there wasn't one, if you left it blank, technically you're correct and you get the mark. It's the same here. If they say, what is the correlation? And there isn't one, then actually you could leave that blank and you would actually get the mark for it still. So that's the kind of like the link and the idea here. So this one would be, let's say, for instance, how high people jump compared to how much money people spend on soap. There's no link between it. Some people can jump really, really high and they love to buy lots of soap. Some people buy so much soap, it's unbelievable, but their jumping ability is not very good. So that's the idea. With this one, there is no link, but it's just to show you in context what the positive and negative look like when compared to two things that have nothing in common. So if we were asked to, let's say, construct one of these from scratch, again, it's going to be a 3-mark question, pretty much the exact same as what we've looked at before. We're going to be plotting one piece of information against another. You would never be given this much data. Please bear that in mind. This is obviously a lot more. It's just to kind of give you an idea or an example. So let's say if we wanted to plot these 11 students' scores of their maths and English tests. So each student has done a maths test and an English test, and we've got their scores here, and we want to plot these on a graph. So we're going to put the maths mark on the x-axis and the English mark on the y-axis. You could do it the other way around. It doesn't matter. Either way is absolutely fine. And then you're going to plot each one on there. So first of all, you need to come up with a scale. So we know the scores are out of 100. So we can go from 0 to 100. And you can apply it how you want, really. So in this case here, we can see we've got this bigger square is going to be 20. So if we work out our scale, that means the smaller square is 10. And therefore, each one of these little squares in there is going to be worth 2. So with that being said, like I mentioned with the accuracy earlier, that means that you could be asked, maybe if someone scored something that was an odd number, then you would be kind of expected to draw the line kind of in between those two lines. They are very lenient with this as well, so please don't worry. They will, you know, so long as you've kind of drawn the line kind of quite clearly and it's in between the lines and not kind of over the line, then you're going to get the mark there. So if I was plotting this data, then obviously I'd draw my two axes and then I'm just going to plot on as I would with anything else. So with this one here, if we were to try and plot this data, first of all, I'm going to say, okay, well, this person scored 38 in their maths. So I'm going to go along, I'm going to find 38. So I've got 20 and 40 here. So this will be 30. So 38 will be 2 squares from the end there. And I'm going to measure up. And what I'd actually do is measure that all the way off the top of the graph. I just, again, get my ruler in pencil, just draw a line all the way up. Then what I can do is say, okay, and they got 74 for English. So 60, 70, and 74. So then I can measure off, and you can see obviously the data points are already there for me, but I can just measure that off and I'll get my mark. You don't have to draw a line all the way off the page. You're not going to get marked for those construction lines. You won't get marked if you leave them on as well. But But it's just a bit easier for you to spot, really. Okay, well, it's going to be on this axis here. That is where everyone on that line has scored 38 in their maths. We just need to find out what their English was as well and plot it against it. So a point here indicates those two scores. But again, bear in mind, you wouldn't ever be asked to plot this amount of data. It might be maybe 4 pieces of information. They'll probably give you a bit of a scale to work with as well. If we were to talk about the correlation here, then we can hopefully see that there is a weak negative correlation there. It tends to be the lower people's math score, the higher their English. The lower their English score, the higher their math score is. So you can see it's that kind of sloping downwards towards the right. And again, if it did ask you about the correlation of this graph, or what the pattern is, what the trend is, what the link is, it's just saying what the comparison is. Take a point from one end, take a point from the other, what's happened. And then just kind of go from there. Okay, so that leads us to what is called our line of best fit then. So the line of best fit is added to a scatter graph to help us make an estimate. The important thing here is if you are ever asked to make an estimate from a graph, then you have to use a line of best fit. A lot of people, you can look at the graph and you can kind of go, oh yeah, it'd be about there. And that's great. But if you don't draw the line in, you're not going to get the mark. So it's going to knock you down 2 or 3 marks potentially. Most of the time, they will say, draw a line of best fit and use it to estimate this, or draw a line of best fit. What do you think the outcome of, someone in this category would be? They don't always though. I have seen some questions where I think there was one, it was about a car, some sales of a car. And it just said, make an estimate as to how much the car will be worth. What you have to do is you have to draw the line of best fit. So just so you're aware of that, to make an estimate from this, you must have a line of best fit. It's a straight line and it's going to have roughly the same amount of points on either side. So like we saw earlier when we were talking about the weak and the strong correlations, the stronger the correlation, the closer the points are, it's a lot easier to draw a line straight through them. By drawing that straight line, we're essentially making a conversion line. That's what we're doing, but it's an estimated one because it's not set in stone. So again, because the line is an estimate, examiners are going to give you a range of answers that you can have and that will be acceptable. So some of the answers, it will range between, if you've put anything from 16 to 20, absolutely fine. They will take that into consideration and they'll consider that with your final answer as well. Apologies, there is a really annoying background sound here. I didn't steal this resource. I took this resource from a colleague of mine because it was very well made, but I've never been able to work out how to get rid of the sound. So I do apologise for the weird, cheesy camera sound. I think there's a twinkle a bit later as well. Okay, here's a graph. I do apologise. It is a little bit hard to see. I do need to try and go through and strengthen up those lines a little bit. This is a graph that compares the mass of individuals, or the mass of 10 different men, and their shoe size. And we're just looking to see, well, is there a link between these? There is this weird little symbol down here. This is called a breakaway line. You don't have to use them, but just so you're aware of what they are. It essentially, if you're starting from anything that isn't 0, you can put these in. So obviously here we can see the pattern is it goes up in 5s. So 60, 65, 70, 75, and so on. But we're not going to start at 0 because no one has a mass of 0. If you have a mass of 0, you have a very serious problem because you don't exist. So by putting this little line there, if you imagine it's like the whole line and it's just been kind of squidged down at the bottom there. So that breakaway line just means that that would continue, but we're not going to look at that part of the graph because it's completely irrelevant. So if I wanted to plot these points, all I'm going to do is read them off. So the next point there, I can see, well, it's someone who weighs 97 kilograms and they've got a size 12 foot. So I can obviously measure up to 97, or I can go to 12, then measure up to 97. Either way, I can plot the point. So when you put all these points on the graph, and again, you wouldn't be asked to plot this many. This is just a working example. But let's say now I want to, as it says at the top there, draw a line of best fit. So if I wanted to draw my line of best fit, I want it to be roughly equal amounts of the points on either side. Please bear in mind, it doesn't have to cross through the axis. So you have this kind of point here where the X and Y axis meet. It doesn't have to go through there. If you think about it, if it was a negative correlation, the line's going to be going down like this. It would never touch that point ever. So a line of best fit then should look something like this. So I've taken my ruler, I've measured it around, yeah, about there, I think. So you can see there, I've got 1, 2, 3, kind of 4 points on the bottom right there. I've got 4 on the top as well. It is all kind of dependent. We don't look at any outliers. We don't look at statistical anomalies or anything like that at functional skills. If you go into further kind of maths or further sciences, you might find that every now and then you get a plot of data which is just kind of way off there. And you have to write about it. You have to explain why it's there. And then you have to either potentially include it or exclude it from the experiment that you're doing. But here you can see this line, yeah, it's pretty good. It could be that you've drawn it a little bit differently. You know, you might have gone, okay, well, I kind of see it as being about there, maybe. You know, that would be a bit of a better line, I think. So you can see there will always be a little bit of variance, not a huge amount. And again, we are only using this to make an estimate because, as we've already said, there is no direct link between the shoe size of people and their mass. There will be a general link, but it's not going to be set in stone. It's not if you have a size 10 foot, you weigh this much. That's never going to be set in stone. Okay, so if we were to talk about the correlation here, then this would be, there's that annoying sound for you. This would be a positive correlation. Again, you could describe that as mass increases, so does the size of people's feet. The bigger the shoe size, the more mass there is. People with smaller shoe sizes tend to have a lower mass. Lower mass people have smaller shoes. Any of them, absolutely fine. Best and simplest way to do it, just positive correlation or negative correlation. Perfect. Now, the other type of question that you get asked is to use the line of best fit to make an estimate. And again, sometimes they don't say use the line of best fit. They might just say estimate the mass of a man with a shoe size of 10.5. So they just asked us that. If we just imagine that this line wasn't here, if I went to 10.5, I'm looking at my data, I'm like, it could be around here, could be around here. We could make an estimate, but the line is really important. The line basically acts as our made-up conversion line. So when I'm working this question out, I'm going to use it as a completely set in stone conversion line. Once you're happy with your line of best fit in pencil as well, do add it in pen. So what is the mass of a shoe size, or what would you estimate the mass to be of someone with a size 10.5 foot or shoe? It might just be you've got tiny feet, but you love wearing big shoes. I don't know. I'm not judging. So in this case, 10.5. So that is going to be here. So I'm going to draw my line up. I hit my conversion line and I measure off. So in this case, it's going to be 87 kilograms. Obviously, with this graph, it's not as specific as the ones that we're going to be using, just as an example. Okay, what would you estimate the shoe size of a man who weighs 69 kilograms to be, roughly? Okay, well, 69 kilograms. I'm going to measure across to my line, and then I'm going to measure down, and I've got a shoe size of 6. So this is, as you can see here, this is linked in 3 different parts. You can see it could ask you, it could have all the data there, and it could just say, state the correlation, draw a line of best fit, estimate the mass of a man with size 10.5 feet. That is the most common type of question for level 2 learners. To see what this really looks like in the exam, we've got this exam example here, and this is from a very recent paper. This was in 2022, I believe. And this is the graph they've given us. So you can see it's a lot nicer, a lot clearer there. So the scatter graph shows information about 12 different athletes who have just run a race. So first thing I want to do, I'm going to have a quick glance there, just familiarize myself with the scales. So I've got time in minutes. Okay, so that's 5. So each one of those little squares represents 1 minute. Fantastic. I've got age in years along the bottom. And in that scale, 1 square is worth 10 years, which means each individual line is a measurement of 2. So just familiarizing yourself. It doesn't have to have the same scale in each kind of way. So question 1 then for this was, here is some information about another athlete. Their age is 36 and it took them 29 minutes to complete the race. Plot this information on the scatter graph. So what I'm going to do, I'm going to measure along. You can go from either way. You could measure up to 29 minutes and then across, or whichever way you want to. I've chosen to find where is the age of 36. So I'm going 30, 32, 34, 36. So it's on that line. I'm going to draw a straight line all the way up and off the page. What I'm then going to do is go up and find time in minutes. Okay, there is a 25, 26, 27, 28, 29. It's going to be there. I'll draw my line across, and then that's where I'm going to put my mark there. You can leave your construction lines in. You don't have to. You're not going to win or lose any marks there. So long as you've got a point at that apex there, you will get the mark. So that's part one of the question, as you can see there, part A. The next part of the question was draw a line of best fit on the scatter diagram. Okay, there's quite a few that you could do there. Again, you can see here, it probably wouldn't go through 0 anyway. But if you're having a look, maybe something like this would be an estimate there. I mean, there are several that you could draw. And again, that's why they will accept a range of answers there. It might be that actually you look at it and you go, actually, it's probably more like, no, that's a bit too shallow there, isn't it? We could all agree on that one. Maybe, yeah, it does have a lot of variance here. So this one here would have, yeah, 3, 4, 5, 3. Yeah, not great. But again, it can take a little bit of time just to kind of be very happy with it, but just be aware that there are multiple different answers for this, or they will accept if you're just drawing a line there, they are happy. They are going, right, you know what a line of best fit is, you know where it needs to lie. That's absolutely fine. So there's 2 marks, fantastic. Our third and final mark then, can you describe the relationship shown in this diagram? So hopefully everyone's quite happy with this one. We can look at that. Well, okay, the time is longer the older that people are when they're taking part here. So there is a positive correlation. As age increases, so does the time taken. You could reverse that. You could say younger people finish the race faster, older people finish the race, it takes them longer, etc. But that is the main thing for level 2 learners. This is really the bread and butter of what we need here. It's these knowing how to draw the line of best fit and how to add this extra information to a graph and state its trend. So we have our last little topic now then, which is about pie charts. So pie charts themselves are, again, they can be on level 1 or level 2. They tend to just be linked in with, I've only ever seen them on level 1 for some reason, but again, we will look at an example. So pie chart or a circle chart, these are best for showing pieces of a whole. So for example, the hours spent in a day doing different activities. As you can see from the little kind of jokey one here, we've got the typical game of ping pong. You've got 95% of the kind of time chasing the ball around the room, 5% of the time actually playing ping pong. What you might pick up on straight away there is, well, it's using a percentage. Because this is a visual way of showing parts of a whole, so we're immediately thinking decimals, fractions, percentages. So pie charts are a really nice and visual way of showing percentages and showing the links between things there. All of them will need a key, so they'll have a section that tells you what each section represents. So obviously we can see there the pink is for playing the ping pong, the purple is for chasing the ball around the room. And they literally work on the simple idea of finding fractions or percentages of an amount. The main link with this and the key concept is that a circle has 360 degrees. It is therefore 100%. So normally when we've looked at these problems, we're finding a percentage of something. We're saying, okay, well, I've got 100%. I'm going to find 1% and then I can find anything. It's the same idea with this. If there are 360 degrees in this circle, I want to know either what's represented by 1 degree or how many degrees does each thing represent. So that's the whole idea here. It's going to be a case of multiplying or dividing by 360 at some point. But just bearing that in mind is going to be very, very useful. The types of questions for these, it tends to be that you're, well, I mean, we'll have a look at the next example and that will hopefully explain. I can give a little bit more information as we go through. So let's say I wanted to construct a pie chart and I want to know what are people's favorite quality streets. I go around, I ask people, I've probably got a tally first of all, and then I've put the frequency in there. So that's the results there, the frequency, and I've got this table here. So what I want to do is I want to put this into a pie chart. I want to see comparatively, what fraction of people out of the total preferred this, what fraction out of the total preferred that. So it's more of a kind of an overall link. So you can see where percentages and fractions link in well. So in total, I've got 18 people there that have obviously submitted their answers, which we can tell this is made up because it claims that 6 people like purple hazelnut, and it's obviously apparent that no one likes purple hazelnut. They are the devil. If you do like purple hazelnut, I'm not actually sorry. I just stick to strawberry cream. They're amazing. Anyway, back to the point. So when we draw this pie chart, it will look something like this. You can see there the representation of it. In this made-up world, purple hazelnut is the most common. So you can see there it has the most space taken up. The great thing is with this, you could measure it, you could work out exactly what percentages it is, or you could work out how many degrees there are in there as well. And we're going to need that when we actually construct this. But at a glance, you can easily see what the most popular is, what the least popular is, and it's quite a nice visual way of seeing these. Most of the time, you tend to get asked to either construct a pie chart or just to simply write how many degrees a certain thing would be worth here. So in this case here, it might say, how many degrees would strawberry cream take up on the diagram? So we just need to know, what's the link here? Well, what we know is that we've got our 2 totals. If this was a percentage, we'd be saying, well, 18 is 100%. So therefore, what does 1% represent? Or what is one person? If we done 18 and we had 100%, if we divided by 18, that would tell me what one person is worth as a percentage. We do the exact same. I've got 18 people in total. My pie chart is out of 360 degrees. So what I'm going to do here is divide by 18. When I do this, it tells me that each result is worth 20%. So just to lay this out in a format that you might be kind of more used to, it's the idea of saying, okay, 18 people equals 360 degrees. It's the whole thing. In this case, I'm not bothered what 1 degree is. I could divide by 360 and that would tell me what 1 degree would represent, but I'm not bothered about 1 degree. I want to know how much space does one person take up. So if I divide by 18, I know one person is equal to 20 degrees. Okay. So now that I know this, I can then apply this kind of scale or this ratio to my working out. Everything is just 20 times bigger, essentially. So for each one of these people, they represent 20 degrees on my diagram. So I'm just going to multiply them all by 20. So strawberry cream will take up 100 degrees of my pie chart, because that's 20, 40, 60, 80, 100. Orange cream will take up 60%, 60 degrees. Purple hazelnut will take up 120 degrees, and so on and so forth. So normally it might be that you're given this table and a little bit of information is missing. Maybe they've got all the information there and orange cream is just missing, and it says fill in the information for orange cream. You'd then say, well, it's 60 degrees and there's 3 of them. It might be that the degrees here are all missing and you fill them in. And it's just knowing that it's, okay, well, if it was on a pie chart, it would be 360 degrees. And it's just seeing the link between them there. You could be asked to measure the degrees on a pie chart. I've never seen that question pop up, but technically you could. So just to remind you, obviously in the exam, there will be protractors and compasses provided, but I'd always recommend kind of nipping into, Tesco's or Asda or anything like that. Not WH Smith's, it's way too expensive. But nipping in there and then obviously picking up one of the little cases are about £2. So, but the thing that they might give you is something that looks like this. So they might just give you this circle with the starting line drawn on, and they might just say draw this information onto the diagram. So I think the harshest question that I've seen is that it asked you to work out, I think there was only 3 categories, but it asked you to work out the number of degrees, or it was add one of the numbers of the amount of degrees and then add all 3 onto the pie chart. So to do this, all we're going to do, we're going to get our protractor. I'm going to set it up here, and we're going to measure out 100 degrees. Now, what you might see here is obviously there is, we've got all these numbers going around this way, up to 180, and then it starts from 0 on the inside and goes around this way as well. That's just so you can measure kind of either way if you want to. For us, we don't need to. We're always going to be measuring to the right, essentially. So I'm going to start from 0. I'm going to follow that round. I'm going to get to 100 there. I'm going to put a little mark there or draw a little line. Move my protractor away, and then I'm going to draw a line across there. Okay, so that's going to be my first section there. What I'm then going to do is measure from that section and carry on. If you don't, if you measure one bit there and you draw a bit here and a bit there, and you end up with gaps, and obviously all of those gaps will be completely filled, but then your pie chart's going to be all over the place. So we want to just kind of follow from this kind of idea. So the first one was 100 degrees. The second is 60 degrees. So again, I'm going to see that point there. I'm going to measure it round. There's my 60. And I'm going to draw my line across there. I'm then going to draw my next line on. So this will be 120 degrees. And then finally, I've got my 40 degrees and my final 40 degrees. And that's going to give me my overall total pie chart there. Okay, so in regards to reading and drawing data, that is everything we need to look at. Again, I have refined this because there was extra information in here, but it was not relevant to the curriculum, so I've taken it out. This is just what you need to know for the exam. What we've looked at today are two-way tables. Again, these are very commonly linked in with our probability. They always tend to be 3-mark questions. We definitely want these to pop up. They're very, very nice. We then had a look at our frequency and tally charts. So again, we did see these in our last session, but hopefully we are a bit more comfortable with them now, a bit happier with them. We know how they work, what tallies are, obviously where we would use them, and what frequency is and what it means. We've then gone a step further and we've spoken about bar charts. So bar charts in themselves are for measuring discrete data, so separate individual pieces of data. And these bar charts are most commonly used with level 1 learners. They can be on level 2, but it tends to be level 1 there. We have a look at our conversion graphs, and hopefully everyone's quite happy with these, and we are happy. This is an easier, quicker kind of visual way of how to look at or how to perform like a conversion, essentially. These are all linked with direct proportion. And again, instead of having to do the sums, we're just going to use that line and it's going to give us a bit of an estimate. So, if we're not too fussed about the absolute exact answer, we've got an idea there. We then had a look at our scatter graph. So we talked about correlations and lines of best fit. And we've looked at the kind of exam style question where we have said, it tends to be that they're asked in kind of like a step process. So state the correlation, add this piece of data, and draw a line of best fit, or draw a line of best fit, make an estimate, and then add this piece of data, whatever order or whatever kind of way they want to do this. We then had a very quick and brief look at pie charts. There are obviously some extra practice materials and practice questions on these. There are some extra questions at the end of the PowerPoint as well. But pie charts in themselves, very, very rare. They don't pop up very often. And so long as you're aware that it's just a visual representation of percentage, essentially. Percent is out of 100. Pie charts are out of 360. If you're happy with that, then you can work out, well, if there's 360 degrees here, and I've got, like we had before, 18 people, well, therefore, if I divide by 18, I divide this by 18 as well, because they're equal. Then each person represents 20 degrees, and hopefully you feel a bit more confident with how to draw that now as well. Okay, so that is going to kind of conclude this session. So I'm going to stop the recording there, and obviously would recommend anyone watching the recording to go and complete the assessments for reading and drawing data on the classroom at this point.